Hi guys, I've received some questions about how to solve systems of equations using substitution. I found a couple of examples that I hope will help you out. We're going to take two equations that are both equal to y as a system of equations. The first equation tells us y is equal to x minus 11. The second equation tells us y is equal to 2x plus 19. Now this is helpful because as a system of equations, we know that having one solution means that these two y's will have the exact same value and these two x's will have the exact same value. Because of that knowledge, we know that this expression must be equal to this expression simply because they both equal y. To help us solve this, what we can do is substitute this value for y in over here to get x minus 11 equals negative 2x plus 19. From here, we solve as normal using the properties of equality. First, I started with addition property of equality to bring the x's together. Next, I'll use addition property of equality again to isolate the 3x, which will be equal to 30. Division property of equality will help us to find out x is equal to 10. Now, once I know x is equal to 10, I can use substitution again to solve for y. First off, I will go ahead and do, for my check, y equals 10 minus 11. That red value is just this value for x. This will tell me that y equals negative 1. With this value, knowing that y is equal to negative 1 and x is equal to 10, I can substitute these two values for what I believe to be the one solution as 10 negative 1. I can substitute back into the other equation. If this is the right solution, I found the correct x and the correct y, then this will make this equation true as well as the first equation true. So we see that negative 1 is equal to negative 2 times 10 plus 19, making this negative 1 is equal to negative 20 plus 19, and we know that negative 1 is equal to negative 1, so this is our correct solution for this system of equations. A second example would be y equals 3 plus 2x. And the second part of that equation will make this negative 3 minus 7y is equal to 10x. Now notice that we don't have y equals and y equals like we did on the previous example, but the work of substitution is still the same. Since we know that y equals 3 plus 2x, we substitute that value here for y, making this work for us. Negative 3 minus 7 times the sum of 3 and 2x is equal to 10x. Using distribution, we get negative 3 minus 21 minus 14x is equal to 10x. Negative 3 minus 21 is negative 24. I'm going to go ahead and add the 14x to both sides to eliminate it, so that I see negative 24 is equal to 24x. Division property of equality tells us that x is negative 1. Knowing that x is negative 1, I come back and I use substitution to find out the other two, or to find out the value of y. So y equals 3 plus 2 times, whoops, I forgot to put my negative 1. So y equals 3 plus negative 2, making y equal to 1. My solution here as an ordered pair should be negative 1 and 1. I can double check that I'm right by substituting back into this equation. So that I would see that negative 3 minus 7 times 1 is equal to 10 times negative 1. I know that 3 minus 7 is negative 10. I know 10 times negative 1 is negative 10. And I now know that my solution of negative 1, positive 1, is correct. I hope this helps you to understand a little bit better how to use substitution to solve a system of equations. Please let me know if you have any further questions on this one.